So to convert back and forth between degrees and radians, we're back to needing a conversion factor, which we can get by looking at a specific angle where I can calculate both values, right? It's measuring both degrees and radians. So to do this, I'm going to start with a circle, and since the size of the circle doesn't matter for determining either angle, I'm going to go with what's easiest, and I'm going to make the radius equal to 1. Now if you look at a 180-degree angle, that cuts off half the circle. Right? Now the total circumference of the circle is 2 pi times the radius. The radius is 1, so this is 2 pi times 1, which is just 2 pi. All right, but that's the whole circle. We don't want the whole thing. We're just looking at a semicircle, right, which is half of the entire thing, which means that the length of my arc cut off by that 180-degree angle is half of 2 pi, which is just pi. All right, so now to get the angle measure in radians, I'm going to go to my formula over here. Theta equals S over R. Well, S is pi. We just calculated it. R is the radius of the circle. That's 1. So a half circle is equal to pi radians, or 180 degrees. And there's my conversion factor. 180 degrees is equal to pi radians. You remember, if you think way back how we first started coming up with conversion factors, the idea is that I want to get a ratio of the two units that's equal to 1, because then I can multiply any number I have by it. So if I divide both sides of this by pi, I get 180 divided by pi is equal to 1. All right, that'll be my conversion factor for going from radians to degrees. And if I take that same equation there and I divide both sides by 180, I get pi divided by 180 degrees. It's also equal to 1, and that's what I'll use to go from degrees into radians. Okay, so let's look at some examples, right? See how we can use these two things. And this really is going to be just this dimensional analysis that we talked about in a whole bunch of other contexts. Right, so if I want to convert 45 degrees into radians, so I'm going to start with 45 degrees. You remember how we do this. It's been a while since we did these conversions. I'm going to put 180 degrees in the bottom, so the degrees are going to cancel. I'm going to put pi on the top. All right, and we can simplify this. I'm not going to go to my calculator just yet. 45 goes into 184 times, so this is the same as pi over 4. Now, it's actually pretty common to write radian measures as a multiple or a fraction of pi. So if I were giving a test and I asked as what's 45 degrees in radians, and the students got to pi over 4 and stopped, I'd be fine with that for an answer. All right, but you could also go to calculator. You could put 3.1415, not whatever, in there for pi, and if you do that, you get 0.785 radians. And remember, radians unitless, so I'm not going to put any kind of unit on there for it. And that'll be the final result. So over here, the middle one, 2 pi over 3. All right, well, there's no degrees sign, there's no units written here. So I'm going to assume that means we're talking about radians. All right, so I want to take 2 pi over 3 radians and convert it to degrees. So I'll put 180 degrees up here on top. The pi goes down in the bottom. These pi's are going to cancel. That's nice. 3 goes into 180 60 times. 60 times 2 is 120. And so 2 pi over 3 radians is 120 degrees. All right, over here, this one's actually a little interesting. I've got 1 radian. I want to know how much is 1 radian in degrees. So I'm kind of really trying to get an idea for how big is 1 radian. And I'm going to do that by putting this into degrees, which I think everybody's kind of more familiar with. All right, so I have 1 radian, and I'm going to use the same conversion factor. I'm going to do 180 degrees over pi radians, and well, it's times 1, right? So this is just 180 over pi. And if you, again, do 3.1415, whatever in there for pi, divide that into 180, you get 57.296 degrees. All right, so 1 radian is a little bit more than 57 degrees. This brings us to the end of our discussion of not just measuring angles, but of measurement in general. In the next lecture, we're going to start off the next chapter, right, where we're going to kind of take the natural next step from measurement and spend some time talking about geometry.